So we have a brake. You can see we have a figure for this band brake question. Coefficient friction തന്നിട്ടുണ്ട്. That's 0.30. That's the coefficient friction. Then the angle of contact is also given as 270 degree. To operate at a maximum force of 400 newtons, the band width is 50 mm. You have to find the band tension and the braking torque. Okay, what you need to find the band tension. രണ്ട് ടെൻഷൻ കാണും, slack end and tight end. So the tension at this two band is what you have to determine as the first question. Then you need to determine the braking torque. These are the two things you need to find. So first, I have written all the given condition. We have a coefficient of friction mu as 0.30, angle of contact, that is theta, 270 degree, but we have to convert it into radians. We can only substitute the value in radians, so that 270 degree will be 4.71 radian. Then the maximum force is given as 400 newton. Then the width of the band is also given. These are all the given condition. We need to determine the F1 and F2 in this band, as well as the braking torque. Okay, we need to find these two parameters what we need to find. Okay, so you can see the figure is already given in the question. This is a figure. The total diameter of the drum is 200, and the distance between the center to the fulcrum is 160, and this two set of distance here. So rotation of drum, they already given the rotation in clockwise direction. Clockwise direction default ആയിട്ട് question തന്നിട്ടുണ്ട്. So we don't need to consider any two set of, നമുക്കറിയാം രണ്ട് ഇക്വേഷൻ ഉണ്ട്, ക്ലോക്ക്വൈസ് ആൻറ്റി ക്ലോക്ക്വൈസ് ഇക്വേഷൻ ഉണ്ട് for force, but already force this rotation is clockwise direction ആണെന്ന് പറഞ്ഞിട്ടുണ്ട്. Again the force is acting downward. So according to our rule, direction of applying force rotation same direction ആണെങ്കിൽ will be considering anti-clockwise equation for solution. നമുക്കറിയാം that's a rule for ഈ ബ്രേക്ക് ഡ്രം ബാൻഡ് ഡ്രം എല്ലാത്തിൻ്റെയും ചെയ്യുന്ന ആ ഒരു കൺസെപ്റ്റ് വെച്ചാണ്. Here we have clockwise rotation, so obviously this will be downward, as well as the force is also acting downwards, right? So both force and this direction rotation are in same direction anangil will be taking anti-clockwise equation, which is opposite direction clockwise. Here it is in same direction, so we'll be considering anti-clockwise equation or counterclockwise equation, and this is the equation for counterclockwise rotation. We don't have the value of ft, but we know the value of b. A is the total distance from the fulcrum to the point of action. That means 100 plus 225 RU, that means 325. B is the distance from the fulcrum to other end of the band. Okay, that is 100. And mu theta, mu is already given. Theta angle of contact, we have to convert it into radian. So we have the value of mu theta. So from there you can find the ft or tangential load as 984 Newton. That's the first step. So directly we have the direct equation under to find the force on the band. This is equation data book under F1 F2 F1 high tension, I mean more force ulla side ulla force, F2 will be the low tension side. These two equations are in the data book. We can find that. We know the value of ft now. We know the value of mu theta, so we can substitute and find the value of F1 and F2. So we got first question answer to find the force on the band. Second, I haven't written torque, braking torque കണ്ടുപിടിക്കുന്നത് is simply T is equal to the torque is caused by the difference of force on the two sides, so that will be F1 minus F2, right? One end will be having a higher force, other will be having lower force, so this difference in force, that is what causing the torque into, so this F1 minus F2 into radius of the drum will get the braking torque. Okay, so if we now have the value of F1 and F2 contributed, and R, we have the diameter of the drum ഉണ്ട്. So multiplying with the radius of the drum, you will get the breaking drum. So this is the way to solve this problem.